All right, so now let's talk about defensive programming. This is an area that coders spend a lot of time if they're doing their job well, because it's very easy to write code that follows our pseudocode and makes sense. But what we don't expect is, because we're the ones that wrote the program, we enter the numbers we know that are valid and we get the output we expect and everything is just fine. So users don't use our program the same way we do, and things can happen that would cause our code to just stop working in the middle of the program. And so we want to catch that. We want to make sure that we make our code bulletproof so that it doesn't crash and give our user that nasty error red message that they have no idea to know what to do with it. So we're going to, well, the book says you're going to play computer. I think you have to play your user and kind of come up with all the scenarios your user might enter. We also call this desk checking. It's also called error trapping. So there's a lot of words for it, for something that's very important for us to pay attention to. We want to check various values that can be put in, not just the value we know will work. We also want to make sure that we put in values for each of our selection structures. So we're going to make sure that we get an evaluation of true. So the first part of our if statement will be evaluated. We'll also check for our else conditions. So you want to check all the conditions to make sure that in fact your conditions are set up properly, that all of the different branches are being evaluated with the proper conditions. You also want to make sure that the user, if the user puts in a 0 and you're doing a division problem where the denominator is a 0, well, that makes the computer very unhappy. So that's guaranteed to make your code crash and burn and give them a big nasty red error message. So that's something else we want to account for, that if they put in a 0, that it doesn't crash our code. So this is one of many scenarios that you have to start thinking about, but at least now we're going to start getting you thinking about what else could the user put in, or what else could happen while my program's running that I should try and catch so it doesn't just stop my program from running abruptly. Here's an example. So I've got some pseudocode in here that's declaring a birth year as integer and the age, and I've set up a constant for the current year for 2017. Get a prompt to enter the birth year. The user's entering in their birth year, and then I'm creating this calculation, current year minus the birth year, to determine what their age is and display their age. Well, if I were just running this code, since I wrote it, I know that 2001 is my birth year. Well, okay, so I stretched a little bit, but the point is I know that that would be a valid response for this input. I put in 2001. The code does the calculation. It says, oh, I'm very happy doing 2017 minus 2001. Those are both integers. I can give you back an integer, and life is going grand. And so at this point, this is not the time to turn in your homework assignment, or even worse, turn your running program into your boss for your client. So instead, what I want you to do is take a step back and say, well, what other values could the user put in that'll cause my code to just crash inadvertently? What else would somebody else put in? Why would you put in anything besides 2001? Well, what if they accidentally hit something on their keyboard, or they weren't paying attention and put in minus 2001? It happens. Don't assume it doesn't. And so now I've got this formula that says 2017 minus a negative 2001 is 4018. Well, it didn't crash and burn, but all of a sudden, because I've allowed an entry that isn't a very good entry, I'm spitting back a very insulting number, or impressive number. I guess it depends how you want to look at that if somebody's that old. But the point is that since I've tested this code properly, I need to do something about if the user puts in a negative number. So now that I have decisions and selection structures, I can put in an if statement that tests to see what that input was. So if birth year is greater than 0, then go ahead and do that calculation, because I know that's a valid integer, a valid number, and I can do the calculation, I can print out the age, and everything will be happy. Otherwise, so now I'm catching that error with the else statement, and I'm saying otherwise, don't try and do this calculation. Just don't bother, because that would be bad. And just let them know, hey, you entered an invalid year. Obviously, I don't know what you input, but I can tell that it's wrong because it's definitely not greater than 0. Okay, I think I got it all. So I've got a good value of 2001. I've accounted for if they put in a negative on accident. So anything else I can catch? Well, sure enough, oh, the output came out. Sure enough, what if somebody just wasn't paying attention to your prompt, which happens, and they put in a May 2001 instead? Well, what kind of data type is that? It's a string, right? So if I try to make the calculation on that string, 2017 minus May 2, that isn't going to work. And so this would cause the code to just break and give the error message to our user, and the program just halts abruptly and they don't know what to do about it. So, and this would work because if birth year is great, but how is birth year is definitely not greater than 0 because it can't even evaluate that. Else you entered an invalid year. That's a possibility. That certainly would suffice, and my code actually now would not crash because I do have this error catch. But how about if we take that a step further? Oops. So now let's add another condition in that first of all we've got the birth year greater than 0. That's fantastic. Now we'll account for if the birth year is less than 0. So we know that were you born that long ago? We're actually being a little bit more specific with our error message because I have a better idea based on my conditions what they might have put in. Well, if they didn't put in a number that's greater than 0 and they didn't put in a number that's less than 0, chances are they didn't put in a number. So now I have another error message that's going up that says, please enter an invalid number. So by way of reasoning, I can better catch that error and send them back an appropriate error message for that particular error. So this is something you have to think about more and more as we write data, as we write our programs. What kind of data will crash our program or return results we didn't really anticipate? You'll spend a lot of time thinking about this. There's lots of different ways to handle these sorts of things, and we'll learn more and more tools to do it. But for now, we can do what we call catch our errors or do error trapping or defensive programming. Depends, all the languages mean the same thing. All the different terms mean the same thing. But it's trying to make sure that we account for the difference in inputs that our users could use and catch it so that we don't have errors or things that we really didn't want to have displayed. So that is the starting of error trapping.